Hello, let's continue our Sudoku adventure with Abiogenesis by PjoeterBliep. So this is a 6x6 chaos construction puzzle. So in each row and each column, we're placing the digits 1 to 6 exactly once each. There are also 6 regions hidden in the grid, orthogonally connected non-overlapping regions, just like Sudoku boxes would be. So it could be the normal Sudoku boxes, probably isn't. But we need to build regions out of 6 contiguous cells, meaning they share an edge, right? They have to be connected. We can't just say, oh, this is part of the purple region, right? It's not connected. This also is not connected. It has to share an edge. Anyway, so we're going to be adding 6 of those to the grid, and they're also going to have 1 to 6 once each. It's like a Sudoku box would. But there's rules for how we're going to draw that. There's going to be only one way to do it, and only one solution to the puzzle, as usual. All right, so we have arrows in the grid. The way arrows work is whatever digits are on the arrow sum to the value in the circle. So if this was 2, 3, 2 plus 3 is 5, we put a 5 here. Now, if multiple arrows share the same circle, that just means they're independent. They independently sum to that value in the circle. So this would be like 1, 1, 2 or something. That's not right, 1, 1, 3. So they would both have to sum to 5 in this case, if the circle was 5. All right, in addition to that, we have some rules about how we're going to build the chaos construction. So digits on an arrow indicate how many of its up to 4 orthogonal neighbors are in its region. So this cell here, the 4 neighbors are these purple cells, the ones that share an edge. And the count here, say it was a 3, says 3 of these 4 purples are in the same region. So maybe it's these 3, and then this purple one is a different region. So basically there'd be a border between them. In addition to that, digits on the same arrow in the same region. So these 2 are in the same region, these 3 are in the same region, etc. And when we say arrow, we mean the line with the arrow attached. We do not mean the circle. So circles don't have to do the counting, and circles don't have to be in the same region as the arrow. All right, and that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself. And I'm going to get started right now. I think the first thing I want to do before anything else is every single arrow caps at 4 because you can only have up to 4 neighbors. Now, some of them are even smaller. This is only 1 or 2 because it's in the corner. Anything on the edges can't be a 4. Okay. I think that's the extent of the sort of the obvious nature of that. Okay, so I'm going to look at this next because we know that these are all in the same region. We're going to call that the green region. And since they're all in the same region, we can't repeat any digits. So the bare minimum would be a 1, 2, 3 triple, which adds to 6. 1 plus 2 plus 3 is 6, which would force this to be 6, which is the maximum a circle can be. So if 6 is the minimum and 6 is the maximum, this has to be a 6. These have to add to 6. The only availability is a 2, 4 pair, so we're going to do that. All right. Since these are in the same region as each other and they're not the green region, we can call it the purple region. What about these? Yeah, so this is only 1, 2, or 3, so it can't join green because it would still be, it would be 4, 1, 2, 3s. So we'll call this the orange region. This can't be a 3 because it can only see these 2. It already doesn't see this one. We can draw the border. In fact, we can draw this entire border here. All right. Maybe we should think about the 2, 4 pair. So if this had all 4 neighbors, it would also absorb this one because of the arrow. So we'd have this 1, 2, 3, 4, 5, 6. This would be the 4. This would be the 2. And this doesn't see 2. And we're already at 6. Okay. I had suspected that was too much to absorb these. So this has to be the 2. And this is the 4, which means these are all purple. And we know that the 2 is going to grab one of these 2. We can give this a new color. We'll call it red. So we can draw this border. And we can actually border the entire purple region other than where 2 might grab a neighbor. So one of those 2. All right. So this has to get out. It's going to be part of red. I should have made that red too. So this already sees more than 1. This sees 2. So it's going to see all 3, and that finishes red. Perfect. Can't do 3, 4, 7. Yeah, adding to 7. So we're doing 3, 1, adding to 4. So what is this? This is 2, 5, 6. Okay, might as well. So what's next? How about this cell here? Nothing else can reach that. This is a new region. Not surprising. It's yellow. Yellow's got to get out. I don't think green can reach this corner either, because that would be too many cells. So this is also yellow. I don't think this is very surprising, though. What about this corner? Or do we want to think about this guy? 1 or 2? Let's think about this corner first. So are we... So something I'm noting is that this sees... The 3 in green is one of these two, and this sees that. So it can't be a 3. So this is a 4, 5, or 6. And the fact that it can't be 3 means this isn't a 1, 2 pair. Now, this here... What would that force? This would be a 1, and this would be a 1. Okay, that's no good. So we're not reaching this corner. It didn't seem likely anyway. 1, 2, 3, 4. So we need yellow. Oh wait, we did yellow. Did I skip a color? Wait, 1, 2, 3, 4. No, it's the last region. It's blue. I don't think orange is reaching this one either, because no matter how orange decides to do it, it's going to lock blue into too few regions. I mean, we can't diverge too much. That's way too much for orange, and we'd have to diverge a lot in order to... Anyway, yeah, there's no way. This is blue as well. Again, I don't know if this is all that helpful. We probably need to just think about this more. This is a pair. Maybe that'll help. A 4, 5 pair. Feels like green's probably going to take that, but... So we need to take... Green needs to take one of these two, at least, if not both. Oh, do we know what this is? Yeah, this is a 1. Okay, sorry, I missed that. This is a 2. So that can't be 2. That can't be 1. This can't be 2. So this is the 2, and this is the 3. Oh, that helps a lot. So the 3 needs 3, and the 2 needs 2. So that means green is only taking one of these. If it took both, this would be a 3. If we're only taking one of these, 3 needs to take both of these in order to get to 3. Because it takes one of these, and then these 2. So what does that mean? Take this one or this one. So we don't take this other 4, 5. Oh, this can't be 6. This is 4, 5 as well. Oh, it's actually 5. So that's 5, that's 4, that's 5. That can't be 4. Oh, we should look at these options. This isn't 1. Yeah, now it's 5 or 6. Okay. So we're going to get... The green is going to get the 6 from one of these two. But I still don't know which one. This 5 cannot be green, so this is yellow. In fact, that finishes yellow. We can just draw the border. Okay. So this can't be yellow. The only region it can be is green, so it must be. And that's a 6. Okay, and green is done as well. So we can draw that. And now this 6 has to be eaten by the purple. All right. We're getting close. So orange has to take this one at least. The 2 means both of these, actually. I probably could have done that. I think there's multiple ways to move forward in this puzzle. I think it's okay what I've done. This is a 2. This is a 1. So this has to be blue, and thus so does this. Because orange already has a 2. I feel like this should get resolved. This isn't a 2. We need a 1 in this column, which goes here. This is going to be whatever this 5, 6 is. So we might as well mark it. Because this 5, 6, whatever it is, needs to go in this column somewhere. Can't repeat in the red, isn't a 1, so it goes here. I feel like I should be able to finish orange. Oh, what about this 3 or 4? Oh, it certainly can't be a 4 because it's next to a green. So that's a 3. 2 plus 3 is 5. This isn't 1. In fact, orange needs a 1. It's going to have to grab this one because we can't get another one. And so that finishes orange and blue. So that should be our regions. All right, so we should be able to solve from here. All the arrows are done. These two are the 4 and the 6. The 6 tells us that's 4, that's 6. This row finishes with a 4. This, we need a 3, 5, 6 here. It's not a 6. This is 3, 5 for the column. Here we need 1, 3, 5. The 1 goes here. This is 3 or 5. Okay. So is it this stuff? We need a 3, 4 pair. Yeah, so this is 3, this is 4. Giving us 5 and 3, giving us the 6 and the 2 and the 5. All right, that's 6, 3, and 5. This is a 2, and then these two digits are the 1 and the 6. And we're done. All right. I mean, I feel like I could have been a little bit more efficient there. Like, I didn't recognize that this couldn't be a 4. I didn't recognize that this was a 2 and thus needed both of these. Like, hard to do all the follow-ups all at once, and it's not natural for me to think that way. But I got there eventually. All right, well, how'd you do?